So a few slides ago, I talked about the three variable gases. There's water vapor, that's a gas that varies in the atmosphere from location to location, day to day. Humidity, right? And then there is ozone. Ozone varies in the atmosphere, it varies in the troposphere, and it varies in the stratosphere, the bad and the good ozone. And then also we have this variation in carbon dioxide. So this actually is looking at carbon dioxide in the atmosphere. The units here are parts per million, so they're relatively dilute in that sense. But they're taken on an island in Hawaii since 1960. And so I'm hoping that you can see kind of two trends here. I want to talk a minute about that. You see this kind of squiggles, okay? That carbon dioxide changes throughout the year, not just at this island in this Hawaiian island, but at all locations that actually has plant life. So this is how that goes. Plants are great at doing what? They take in carbon dioxide and they return O2. Okay, so of course O2 is oxygen. So the carbon dioxide goes away when the plants are very active. Now there is a lag between when that happens. So actually spring plants are coming to life, and they actually here in the fall kick in their photosynthesis, so we see the most amount of carbon dioxide sucked up by plant activity. So in the fall we have our minimal CO2, and in the spring actually we have our peak CO2. Might seem a little backwards, but that's the real deal. The other trend I hope you see is actually from year to year, 1960 to 2015, and I'm going to show you some current data with regard to CO2 concentration at this given location. So do you see that increase right there, increase in carbon dioxide, this variable gas in the Earth's atmosphere? And it's a couple things here with regard to human activity, increasing carbon dioxide in our atmosphere. Of course, burning fossil fuels are anything gasoline, coal, oil, those are all fossil fuels. When we burn them, we actually get energy, but we also release carbon dioxide and actually H2O vapor, which is just fine, okay? But it's this carbon dioxide gas that is increasing carbon dioxide in our atmosphere. The other thing that unfortunately has happened is that humans have cleared regions of forests for their wood product. They've cleared them because they wanted the wood, and they've cleared them because they wanted the real estate. So unfortunately, if you take away the forest, those are large chunks of plants that what did they do? Well, they took in carbon dioxide. So we've kind of lost a little bit of a way to what we say tie up carbon, convert carbon dioxide into something that's not not carbon dioxide. I want to take you out to see if this works. I have this little marking down here called latest data. So I'm going to take you to a place where everybody would like to be on that Hawaiian island, gathering data with regard to carbon dioxide levels. So I kind of just look at I don't look at this every day, obviously. Okay, you see we're at 403.56 parts per million. And I remember, gosh, I can't remember how long ago it was that we reached 400 parts per million, and that was a big, hairy, sad sort of deal. One of the captions over here actually kind of talks about why this dip, and the caption suggests it might have been related to hurricane activity. Okay, but yeah, 403 and rising. So I like this website. It also goes back and gives you some historic data. I'm going to go back to the 10,000 years. Okay, so this is carbon dioxide levels in the atmosphere. So we see 250 parts per million, 300 parts per million. Okay, and let me pull up my pen here. This is sometimes called the hockey stick. The hockey stick look at carbon dioxide in the atmosphere. So I mentioned 250, 300. Of course, now we're up here at 400. So this was what it was thousands of years ago. Carbon dioxide, you kind of see some. And then this is what it's been like since the Industrial Revolution, this big uptake. Okay, does it look like an L? Okay, a hockey stick. So that's the concern there, right? Carbon dioxide in our atmosphere. Let's see if I do this, will it? No, I want to go back. I think this will do it. So this next slide says, who cares about carbon dioxide in the Earth's atmosphere? And I'd say we do. We actually, Earth has had this sort of phenomenon called the greenhouse effect going on way before humans and way before the Industrial Revolution. Okay, but now we have what's called the enhanced greenhouse effect. And let me kind of tell you how the greenhouse effect works. So we talked about the different wavelengths of light, or excuse me, different wavelengths of electromagnetic radiation. Remember I talked about that with Rayleigh scattering a little bit ago. I said here we have gamma rays. Okay, here we have radio. Okay, somewhere in here we have visible. Okay, a little bit longer than visible we have IR. A little bit shorter than visible we have ultraviolet. I don't know if this is all kind of coming back to you. Okay, so these are shorter wavelength, and these are longer wavelength. And actually longer wavelength, these are less energy, and these are more energy. So that's kind of what we have going on. So what happens is that visible light this wavelength, okay, this wavelength, okay, can go ahead and penetrate glass. Okay, so here it is going through glass. And actually, this greenhouse effect I'm going to talk about happens in our cars. If there's a nice sunny day, the sunlight comes in your car, it can react with stuff in your car, interact with stuff in your car, and this little thing right here, actually it heats up, it gets those particles in your car moving fast, and it turns from visible into infrared radiation. Okay, so infrared is a longer wavelength. It's a less energetic wavelength, but infrared actually is blocked, a lot of it is anyway, blocked by the glass. So it's kind of trapped in here, infrared. And I don't think I've mentioned it yet, but infrared actually is thermal energy or heat. Okay, so basically we have visible light interacting, being converted to heat, and it can't leave the glass. Okay. Now over here, this figure actually says we have visible light interacting with stuff on the Earth's surface, and then also heating this up, infrared radiation, and this radiation is re-radiated away, and as long as there's nothing to stop it, it goes away and cools off. So, okay. Now, I can see I need to add one more thing here. All right, so here we see kind of this blob right here that's representing a portion of the atmosphere. Let's just say in that portion of the atmosphere, let's go ahead and add CO2 gas, okay? Now CO2 gas acts like a glass pane. The carbon dioxide actually acts to absorb some of that heat. Okay, so we have kind of a warmer layer here and kind of reflect some of that heat. It traps it. So the point with this figure, now that I'm looking at it, it shows a thick line coming up. That's the infrared radiation, that's the heat, and a thin line leaving. So that's trying to kind of show you how it's being trapped here. So bottom line is carbon dioxide in the Earth's atmosphere acts very similar to what a pane of glass acts like in a greenhouse. So again, has this effect of the Earth's atmosphere acting like a blanket? Has this carbon dioxide greenhouse effect been around for a long time? Yes. But we have what's known as the enhanced. As our CO2 levels keep increasing, that greenhouse effect is increasing as well.